Okay. So, okay, so we got the first step where we got to get everything on one side and the other side equal to 0. So, Hema, what do I do next? What do I got to do here?
Do you multiply, get a common denominator?
I got to get a common denominator. How are you going to help me get a common denominator? What do I got to do here?
You would multiply 3x minus 15 to the 5.
That is almost 100% correct. Let me what I really need to do here, let me kind of move this over a little bit so I have some room. Greater than or equal to 0. I have to multiply, yes, I got to multiply 3x minus 15 over 3x minus 15 to 5. Right, and I know you would have done that, but I'm just trying to be clear on the expression. So Alexis, why is it that I'm allowed to do this? Why am I allowed to multiply 5 by 3x minus 15 over 3x minus 15?
Because like all integers are like under 1. Like it's like I don't know how to explain it. It's like 5 over 1. So yeah. So like that's why you can do that.
Well, but why am I allowed to multiply it by this right here? I mean,
because you need a common denominator.
Well, that's true, but if I needed a common denominator, couldn't I just multiply it by like 8 over 3x minus 15? Could I do that?
No, because I did this original. Is it because you also? I had the same. I did that initially, and then I like checked my answer, but I don't remember like why.
Okay, so what is special about 3x over 15, 3x minus 15 over 3x minus 15? There's something very special about that. You know. What's it equal to? 3x minus 15 over 3x minus 15, what's that equal to?
5?
No. What is 7 over 7 equal to?
1.
Yeah. What is 7x over 7x equal to?
1.
So what is 3x minus 15 over 3x minus 15 equal to?
1.
So you can multiply anything you want by 1, right? And it doesn't change.
Mm-hmm.
You see what I'm saying here?
Yeah.
I should put that out as a question on the test. I'm going to do that. Maybe. Yeah. So write in your own words, 3x minus 15. 3x minus 15. Yeah, I might do that. Well, I already have another write in your own words question, so maybe I won't do that. But that's why I'm allowed to do that. Okay, so I'm going to get a common denominator. So my denominator is going to be 3x minus 15. And then Angie, what's going to be in my numerator?
2x plus 7 plus 15x minus 75.
That's right. Right. I distributed this 5 to both those pieces right there. My denominator now is 3x minus 15. Is everybody okay with that? Yes. Okay, good. And then and that this has to be greater than or equal to 0. Marissa, can you help me simplify my numerator here?
Yeah, so then it's 17x and then 68 plus 68.
Yeah, it's minus 68.
I mean minus 68.
Yeah, and that's going to be over 3x minus 15 and has to be greater than or equal to 0. We going okay so far? Yeah? Okay. Bridget, what's next?
You have to do the top is equal to 0.
Okay, so and what's that going to give me when I do the top equal to 0?
It's gonna it like the denominator says something with the denominator and I can't remember.
Okay, so I need to find my intervals. Okay, what defines the intervals?
The denominator?
Okay, hang on. Helena, can you help here?
Yeah,
So what do I need to define my intervals?
a number line.
Well, I'm going to need that, right? But then I'm going to have to put something on the number line. What am I going to put on the number line?
Your zeros and your vertical asymptotes.
Okay, I'm going to put my zeros and my vertical asymptotes. Bridget, are you okay with that? Okay, Bridget, which one's going to give me my zeros and which one's going to give me my vertical asymptotes?
Doesn't the numerator give you the numerator gives you the zeros?
That's correct.
Okay.
So the numerators, and you know, the way I write it here, I always write zeros and then vertical asymptotes, right? So you can look at it the same way, you know, it's like, this is the numerator, that's the denominator kind of a thing. You see what I'm saying? Right? Okay, but so I definitely need to find my zeros and I need to find my vertical asymptotes. But before I do that, there's something else I need to do. So I'm going to take a volunteer on that. What else? What do I need to do before I find my zeros and vertical asymptotes? Yeah, Esme, what?
You graph it.
Thank you very much, right? Graph it. Well, I mean, I already did a bunch of algebra. I don't want to do any more algebra if I'm going in the wrong direction, right? So I want to go in the right direction. I'm going to graph it. So let me just shrink that a little bit. And let's open up Desmos instead of the calendar. And I'll shrink that. Okay, good. So my initial expression is after I've moved this -5 to the other side. So my f of x is my kind of my original here, which is 2x plus 7 divided by 3x minus 15, 3x minus 15, and that whole thing is plus 5. So that's kind of what part of my function looks like. And then I simplified it into this blue one right here. So we'll call that g of x, and that equals 17x minus 68 divided by 3x minus 15. And it's looking to me as if I did it right, because let's zoom out here a little bit, because the graphs are the same. Everybody with me here? Yes. So, I mean, Desmos is allowed on tests. I just can't see any reason why you wouldn't do that. You know, it takes a couple minutes and it might save you like gobs and gobs of time and get you the right answer for that matter. So let's zoom in just a little bit here, and let's take a snip of the graph so that we can look at it. Okay, and we'll put that on the next page right here. So, actually, let me just look at the graph one more time here. It looks to me like if I click on the graph, it looks like I have a 0 right here at +4. Do you see it? Yeah. And it also looks like I have a vertical asymptote at 5. So I'm thinking about that. I've looked at the graph, and now I have to just see if my algebra matches up with what I have on my graph. Here we go. That's what I want. Okay. So So Bridget said the zeros are the numerator, the vertical asymptotes are the denominator. So let's go 17x minus 68 equals 0. So 17x equals 68. X equals 4, because 17 into 68 is 4. And that is confirmed on my graph right here. Here is my 0 at x equals 4. And then I'm going back to my problem here. I need to find the vertical asymptote. So I'm going to go 3x minus 15 equals 0. So 3x equals 15, x equals 5. And sure enough, that looks like where I have my vertical asymptote. In fact, I'm even going to draw that in here so we can look at it a little bit more nicely. Right there at 5. Okay, so I have my zeros and my vertical asymptotes. Now what do I do? Camila, what do I do now?
Now you can do like the line, right?
The number line. And what am I going to put on the number line, Camila?
You're gonna put 4 and then 5.
That's exactly right. So I like to make the zeros as solid lines and the vertical asymptotes as dotted lines. But that's all I got. I only have 4 and 5. So Sophie, can you tell me what my intervals are going to be?
Yes, the first one is negative infinity to 4,
Good,
then 4 to 5,
good.
and then 5 to infinity.
5 to infinity. Everybody still good? Good with this? Yeah. Okay, Sienna. Sienna, I would like you to give me some numbers to test in each interval. Can you do that?
Yeah.
Okay, so what should I test in this interval over here?
3.
3 works great. And what about the next interval? What should I test in there?
4.5.
I think 4.5 works great. And what should I test in the last interval?
6.
Looks good to me. Okay, so I'm going to take the easy way out, and I'm going to test them in Desmos. So so Isa, I have a question for you. There? Okay, Joanna, I have a question for you. Are you there?
Yes.
Okay. Do I need to test it in f of x or g of x?
You need to test it in g of x, I believe.
What if I test it in f of x?
Wouldn't it be like just about the same?
Yeah, they're the same thing. Doesn't matter. Very good. Yeah. So don't let me gaslight you. Okay. So I'll test it in f of x, but it'll be the same in g of x because they're the same. That's what we did. We tested it to make sure they were the same graph. So if I go f of 3, I find out that that's a positive number. So I'll write a plus right here. And I'm going to test f of 4.5. And that looks like it's a negative number, so I'll write a minus right here. And then the last one was 6, so let's test 6. And that's a positive number. So let me, oops, pen's upside down. Come on. That's a positive number. So I have positive, negative, positive. And I'm looking for where is it greater than or equal to 0. So Katie, can you give me the answer?
It would be negative infinity, comma 4, and the 4 would have like a bracket.
The 4 has a bracket. Negative infinity and positive infinity always have parentheses. That's good.
And then union 5, comma, infinity,
And brackets or parentheses.
parentheses.
Why a parentheses around the 5?
Because it's a vertical asymptote, not a 0.
That's right. It's not really part of the, it's not part of the function. There is no x there at 5. Pretty good? We feeling okay with that? Okay, so I have another question. Wrong graph. Where's the graph? Here's the graph. Okay. In fact, let's just look at it here on Desmos here. Let's change this to my x-axis here to, I don't know, 700. Not really a good example. Okay, I'll come back to here. Who am I going to ask? Tiana, I'm going to ask you this question, right? Well, so you saw in the graph here that this branch of the graph, you see how it's kind of like sloping downward. Can you see that?
Yeah.
Okay. And if it keeps sloping downward, isn't it someplace that it's going to also like cross the x-axis and then be negative if it keeps sloping downward?
No, it's never going to go past the x-axis.
How do you know?
I know we talked about this last class, but is it because it means like there would be another x, but we only have like 1 0. So
that's exactly the right answer. I know it's never going to cross the x-axis, because if it crossed the x-axis, I'd have another 0. And my algebra tells me I only have 1 0 at x equals 4. That's the only 0 that I have. So it's going to go on forever and ever and ever. It will never cross the x-axis. Are we okay with that? Okay, so we feeling relatively comfortable with this stuff? Yes? Any other questions? All right, so I'm going to take this up. Wait, I got a chat going on here. What's going on? That's fine. I'm going to take this recording. I'll put it. I'll send it out to everybody. And I'll also put it in the video index. There's a couple other problems in the video index if you kind of want to look at them. You know, I know you're all like super excited to start on the logarithm section. Yeah, but we're not going to do that today. So we'll start logarithms on. Well, we'll probably start logarithms in the short class on Tuesday. You know, we'll just kind of touch on it maybe a little bit, because actually the beginning of the logarithm section has a fun game that'll give you some interesting insights into logarithms. So so that's it. We're done. Have a longer break. Have a nice weekend. Be safe, and we'll talk to you later. Okay. Bye.
Thank you.
Thank you.
Hi, Mr. Jenkins. I sent you, sorry, I was using the restroom. I was like trying to text Jordan and let you know. And then, but the second thing I had to tell you, I sent you an email saying that I have to take my little brother to doctor's appointment, and I have to go to one too. If that's okay for next period, for 8th period. But I already asked Caitlin Beltran for notes.
Okay.
So I'll have them. And if I have any questions, I can email you.
Yes, I'm trying to think. I think I recorded the class from the other period.
Okay.
And so, and then that's the material I'll be covering. So I'll double check and I'll make sure, because it is new stuff that we're learning today.
Okay.
All right.
Thank you.
All right, good. See you later.